Hello dear students, I am Poonam Lakra, Assistant Professor, Department of Computer Application. In today's session, we'll be learning about one of the most common algorithm, that is divide and conquer algorithm. The learning objective of this session are to understand what is a divide and conquer algorithm, the fundamentals of divide and conquer algorithms, and the applications of divide and conquer algorithm. To start, what exactly is this divide and conquer algorithm? Divide and conquer algorithm is an algorithm pattern in which the design is to take a dispute on a huge input and break the inputs into minor pieces, decide the problems on each of the small pieces, and then merge the piecewise solution into a global solution. This mechanism of solving the problem is called the divide and conquer strategy. To understand more, let's see what exactly the process is. The divide and conquer algorithm constitutes of three important steps. The first, divide the original problems into a set of subproblems. Second, to conquer, solve each subproblems individually, recursively. Third, and finally, combine. In this, you have to put together the solution of all the subproblems to get the solution to the whole problem. The fundamentals of divide and conquer strategy. Here, there are two important fundamentals. One is your relational formula. Second is stopping condition. In relational formula, this formula here we generate the different techniques given. After the generation of formula, we apply the strategy, that is, we break the problem recursively and then solve the broken subproblems. In the second pattern, we have a stopping condition. In this, we break the problems using divide and conquer strategy. Then we need to know that for how much time we have to apply this divide and conquer. So the condition where the need to stop our recursion steps of divide and conquer algorithm, we have to apply this stopping condition. Finally, after having this algorithms, we need to know what is the most important advantage of divide and conquer algorithm. This strategy tends to successfully solve one of the biggest problems, such as the Tower of Hanoi, which is a mathematical puzzle. It is challenging to solve complicated problems for which you have no basic idea, but with the help of this approach, we lessen the effort by dividing the main problems into two halves and then solve them recursively. This algorithm is much faster than the older algorithm. One of the most important aspects is that it not only efficiently uses the cache memory without occupying much space, but it also have a simple subproblems within the cache memory instead of accessing the slower main memory. Next, it also bring about the most proficient in counterpart brute force techniques. This algorithm also inhibits parallelism. It does not involve any modification and it is handled by the systems incorporating parallel processing. Now, to understand the applications of divide and conquer algorithms, there are various algorithms which has incorporate this strategy. One of the most common one is the binary search. In the binary search algorithms, we basically divide the entire search into two halves. It works by comparing the target value with the middle element existing in the sorted array. And after making the comparison, if the values differ, then the half that which cannot contain the target will eventually be eliminated and then the search will be continued for the next half. Then this process continues till the target is being reached. The another most important one after this binary search is that is the quick sort. In the quick sort, we have this efficient sorting method by having a partition exchange method. It starts by selecting a pivot value from an array and after dividing the rest of the array element into two subarrays, the result, the partition is made by comparing each element with the pivot value and then the result is held with the greater value or the lesser value and then they sort the array recursively. The another one is the merge sort. In this sort, we make the comparisons. Again, it starts by dividing the array into two subarrays and then sorting them recursively. After the sorting is done, the merge is being made for both the result. Another one is the closest pair of the point. This basically is used in the computational geometry This algorithms emphasize finding out the closest pair of points in a metric space given the endpoints such that the distance between the pair of the points should be minimal. Thank you. I hope you like the session.